Hey everybody, Shawn here from theautomationblog.com, and in this episode of the Automation Podcast, I sit down with Mark Arnold from SMC to get an overview of SMC's EX600 Wireless IO system. Mark, thank you for coming on the Automation Podcast and taking time out of your busy day to explain to us what the EX600 wireless system is all about.
Well, thank you, Shawn. It's a pleasure to be here, and I appreciate you welcoming me into the program here. So with the SMC EX600 wireless system, it's a unique device that allows communication from a base unit to a remote unit, and it is typically used for control of solenoid valves and feedback and sending of I/O signals remotely. So what we have is a base unit that can communicate to remote units in up to a 10-meter radius. The base unit is hardwired through an industrial Ethernet protocol back to a PLC. The protocols that we offer right now are Ethernet IP and Profinet. So what are the advantages of this system? Typically, obviously, you would have less wiring time between components, and you would speed up your construction time. One of the biggest advantages is the communication or COM cable is not needed. And if you have a piece of equipment that is moving, such as a robot arm, where you mount a solenoid valve manifold or I/O devices, you don't have to worry about the flex of that cable repeatedly back and forth. And this is very typical in a robot arm, where that cable flexing back and forth will deteriorate quality over time and eventually break and cause a communication loss and result in a large amount of downtime for the customer. Another advantage that's pretty simple here is that it's very flexible to move your equipment around, so you would only have to run a new power cable or an air line if you're using a pneumatic solenoid valve.
Yeah, I think the robot arm, that flexible cable, that's usually very expensive. So, to get something that's rated for high flexing, so I can definitely see that side of it.
Yes, and in talking to our customer base, and it was actually probably the number one application, and the customers that came to us and looked at this type of system for us to create, they could have up to 8 hours of downtime of having to troubleshoot the communication problem and rerun a new cable in their robot. So obviously with companies such as high production automotive environment, where downtime is $10,000 a minute or more,
Wow.
8 hours of downtime is very, very problematic. So anything that can eliminate or reduce this is very much a success for them. So on the feature side of things, the one base unit can have up to 1,280 inputs and 1,280 outputs. That is with up to 127 remote units. So that seems quite a bit, and it is. Typically, we would actually recommend up to 15 remote units maximum. It's just like any network situation. You get too many devices on the network, you start running into bandwidth issues. So it's something that we really want to, try to limit in a lot of cases. With each of these remote units, you can have 128 points of inputs and outputs. So it's still pretty flexible on each one of the remotes. One of the things that's also really unique too is if you're doing something such as a tool change and you're connecting in and powering up a different remote unit, it has a connection time of around 250 milliseconds. So it's a quick connect type connection on the remote system. So again, for tool change situations, it's a real quick uptime. You're not waiting multiple seconds or even a minute to boot up the remote unit. So it's a very quick changeover for a tool change process. As we mentioned before, the communication distance is 10 meters, and that's in a spherical radius from the base unit to the remote unit. That's the recommended range. There are things that may affect it, such as solid objects in between the base unit and remote unit that may block the signal and deteriorate the signal. You can also possibly stretch over 10 meters, but we do recommend 10 meters as the maximum.
So maybe a good rule of thumb is to make sure you have line of sight between the two products. This is rated for on machine mounting, right? This is IP. What IP is it?
It is IP67, so yes. So you
Okay.
could remount both the base and the remote units out on machines. So it handles, most uh, obviously light wash down, dirty environments, things like that. So unless you need a caustic wash down, it's a very good product because you're using M12 connections on all the electrical connections on the units themselves.
Excellent.
So when we talk about wireless, a lot of the things that come to mind in the industrial world is, well, how reliable is it? How noise resistant is the product? So what we do offer this, or we design this at a 2.4 gigahertz frequency. And with the gigahertz frequency, you're high enough frequency over most industrial noise sources, such as AC and DC welding, electromagnetic heaters, motor drivers, things such as that. So we're above most industrial noise sources with the frequency. At 2.4 gigahertz, you do have to be a little bit concerned about any wireless LAN, RFID, or Bluetooth that operate. However, we do not operate on wireless LAN, and we don't run in the Bluetooth environment either. We're in the same frequency ranges, but we use our own proprietary protocol. And we'll talk a little bit more about some of the details we have to avoid interference problems. So what we do on spread spectrum of frequency hopping. So we hop over 79 different micro frequencies around the 2.4 gigahertz range. So every 5 milliseconds, we change frequencies. So if there is a potential interference with another device or another frequency, subfrequency in the 2.4, we quickly change to another micro frequency. So this prevents us from being interfered with and also possibly interfering with another communication device. The other thing we do is we do keep our power limited to about 1 milliwatt and the radio emissions power, so we don't want to interfere too much with other devices. So that's part of our limitation of range, but it's also just a prevention of problems with other systems. The other thing that comes up a lot when people talk about wireless systems is security. So, first you have the controls guys say, hey, what's the concern? But even more so, the IT people in the facility, they don't want introduction of another wireless device because they look at it as another path for someone to get in. And this is our own security encryption that we use. It's proprietary encryption. What the thing that I look at is, yes, it is wireless, and yes, somebody could listen in and be able to see what's going on. But with the encryption, the limited amount of range of the 10 meters and the inability to pass through solid objects, like a steel wall, or it would be, to me, you would have to have very, very high-end equipment to be able to listen in external to the facility. Let's just say somebody was driving by and had a laptop in their car. They would need some kind of high-end parabolic antenna to be able to try to listen in. They would then have to be able to understand the protocol and be able to view it and see it and be able to do something with it. And there's just so many, honestly, in my view, so many easier ways to go in and hack into systems. With today's automation environment and manufacturing, there's a lot of maybe workforce shortages, and so I would think, and this is just me being, putting on my little hat of, hey, let's the white hat, black hat kind of thing, and being a hacker mentality. Why not get hired as a temporary employee, come in with a USB drive, being able to get into a system that way would be so much easier than trying to hack into this system with high-end equipment. I just think the
Yeah.
probability is pretty low. No system's unhackable. I say that, but I don't think this is a vulnerability point because it's not wireless LAN. It's not something somebody would be looking for unless they knew what they were looking for. Then they would have to hack the encryption and then be able to go up, backwards up through the PLC and get into either intellectual property or be able to shut down a system. So it would be difficult. I would think it's not a little bit difficult. So that's just kind of my answer I have for the security side of things. Again, somebody could theoretically do it, but it's very improbable in my opinion.
Yeah, I also think it would be irrational to try to hack this, because if you can get within 10 meters of the control system, all you probably need is a copy of Studio or TIA Portal, and you'll be able to. Most PLCs aren't passworded. The vast majority of PLCs aren't passworded. So if you get that close, you could take over the whole control system with a copy of the software, even a demo copy of the software, without having to try to reverse engineer your encryption. So,
Exactly.
trying to blast, trying to have an antenna powerful enough to blast through the walls of the building, and overpower the base unit that's 10 meters away. I just don't think that feasible. You might microwave yourself before you could get enough power from outside to try to take control of the robot arm. So yeah, I agree. I see what you're saying, and I agree with you. It's to me that 10-meter range is the security means that's protecting you from outsiders, people outside the building, being able to hack it, because it just doesn't have the reach.
Exactly, exactly. So again, it's always possible. There's always ways to do things. It's just the probability of it's low, and there's easier ways to be destructive or steal intellectual property, in my opinion. So, there's always security issues, but I think this is a highly unlikely one to be a pathway for a someone with a malicious intent. So,
Yeah, quite honestly, if you got within 10 meters, you could just cut the wires going into the base, and jumper them and get
yeah,
the arm to do whatever you want. No laptop
exactly,
needed. Yeah.
exactly, exactly. All right, I'm gonna continue here. So with the units, it's very similar to our hardwired EX600 system, which we use for our pneumatic solenoid valve interface. But the other thing that we offer with this is the I/O modules. So we have digital and analog I/O modules for this, and you can attach up to 9 of these modules to both the base unit and the remote unit. So you have a lot of flexibility with these, and they're pretty easy to program and set up. And with this, again, you can do these remote units without the solenoid valves. You can attach a block-off plate on that and just use them as I/O, as remote I/O units that are wireless. So if the application doesn't require pneumatic solenoid control, then you can just do as a pure I/O. The configuration of both the base and the remote unit is done through SMC software. That's free software, and the actually through an NFC card reader with a USB. So you attach this to your laptop, put the NFC card reader on both the base unit when it's being configured and the remote unit. And so what we're doing here is we're pairing these uniquely, almost like a Bluetooth pairing. You set up the base unit in a pairing mode, and then you look at, the remote unit in a pairing mode, and then the base unit looks for unpaired remotes, and then you match it up and put it in the I/O slot that you want. You also have the ability for the base unit is to set the IP address, configure the number of occupied bytes. So there's quite a bit of configuration that's done through this software and the card reader, and it makes this a very flexible system. And with the card reader, part of that on the remote units, we're just preventing any possible ingress. And so we maintain the IP67 rating without having any ports on the remote units themselves. So you don't have to go in and plug in any particular device to it. You just maintain that rating through the NFC card reader. For the Ethernet IP version, there is also a web browser built into it. So you just simply log into the IP address where the Ethernet IP unit, and you can go in and monitor the I/O for both the base unit and the remote units. You can force I/O through the web browser, and there's another feature that's actually on both the Ethernet and the Profinet version. There is access to CSV files that are recordings of the statistical data on the wireless itself. Things such as the communication strength in decibels, the number of retries to communicate between the base and remote, and it's every frequency you can actually look at that signal strength. So there's a lot of statistical analysis that it is capable of through the web browser. So this allows you to get a better handle on what's going on in the wireless environment for your system. It allows you to come in and say, okay, is this the best location for my remote and the base unit? As we mentioned before, line of sight is best. There is a little bit of bounce with the 2.4 gigahertz, but this allows you to go in and see, is the signal strength good? Is there a number of retries that's excessive because it's low signal strength? So this is a good tool for going in and seeing, is your setup the best? So if you're an OEM building equipment, if you've got it set up in your, let's say, a cell in your shop, you can go in and see the best location. But you might want to look at this again when you're out on location at the end user, because there may be some other types of signals that are coming in at a certain frequency. So then you can see, okay, I'm getting something that's causing me to retry on this frequency all the time. So you get a little bit of an idea for troubleshooting, and there could be the potential to bring in a wireless signal analyzer on third-party device and look at that particular frequency and what's causing that particular noise. So there could be some settings on the other device that can be used to change that frequency, or look at what is the cause of that. So this is an analysis tool. It's pretty powerful. This information is stored in the base unit until it is cycle power. So there's quite a bit of data that's in there, and we'll see what's going on with it and be able to troubleshoot.
I can definitely see this giving me peace of mind if I'm deploying this system. It's all set up, it's all wired in, it's working. I can pull the CSV out and just have that peace of mind that there's no, that this, I have high signal strengths and everything's working good. Because quite honestly, you'd want to know that before you left and let the system run, right? So
Exactly.
yeah, that's great. That's a great feature.
And one of the things that we had one of our end customers do, because they were very familiar with the system, they're a user that has over 1,500 units installed, actually in automotive weld cells. Because they knew this feature, they actually set their own standard of number of retries and minimum signal strength. So they were set that to their machine builders and for themselves. So they went in and made a spec based on this data analysis. And this is what we have determined is the reliable system. So when this is built and set up, you need to go in and check all these values. So it's, I think, a good tool to be able to use, again, to give that peace of mind, as you said. So, just getting into a little bit of specification types of things. With the radio protocols, it's IEEE 802.15.4. The encryption's SMC. The signal spread methods, frequency hopping spread spectrum. And of course, we mentioned it's the 2.4 gigahertz ISM band. So from 2.403 to 2.481 on the 79 channels. The communication speed is 250 kbps, and we say on the data latency it's a minimum of 5 milliseconds. When you start talking about latency, this is a value that's again, as an engineer, you sometimes say you get answers to a question. You give answers to a question. It depends. So it depends on the environment and what's going on, what's on the, on the network, the bandwidth, the distances, all of those things are things that come up. Generally, when you're looking at these systems, you're going to do more of a, let's say, I'm trying to think of the way I want to call it, but you're not going to do a high-speed transfer line, maybe a packaging converting line. You're not necessarily going to use a wireless, system. But if you're doing something that's very cyclical, such as a automotive weld cell, for example, that the cycle time is much longer, that you don't need as real-time communication or super fast communication, this is a great problem solver for those communication issues. Something that's also, it's a little different for us is because it's a radio device, it must pass certification in the country that it's being used. Obviously, for the United States, it's FCC certification. For Canada, it's IC certification. Then you look at the European Union, you have to have CE certification. So, each country has a different standard. So we looked at a lot of countries and we made sure that we passed each of those standards. And so pretty much any heavily industrialized country in the world, we are going to be available and pass the radio law. And we're continually adding to that. So if you are a machine builder that builds in the US but ships overseas, we are very likely to be able to have the certification to be able to use this radio device in that specific country. I want to get into a couple more specific examples of where you might want to use this. As we mentioned, end of arm tooling on a robot, that continuous flexing of the cable is always problematic, and having the ability to not have to maintain that is obviously a huge plus. The other side of, if you're doing tool changes on a robot, again, the quick connection, the 250 milliseconds uptime is fantastic. The other thing that on the tool change, most of you are probably familiar with industrial connectors for power are pretty robust. Something that's having to be plugged and unplugged many times. But if you're doing a network connector, it's a lot more critical to have a quality connector. So if that connector is repeatedly plugged and unplugged, eventually you may get some deterioration of the communication. It may end up with noise in it or completely fail. So having this wireless communication on tool changers is a huge, huge advantage. Another application that comes up a lot is a rotary table. Most of you, again, are familiar with slip rings. And slip rings are good for transmitting power to devices that are mounted on a rotary table. But having a industrial Ethernet connection through a slip ring is possible, but it becomes very expensive to get a quality unit. And I talked to one customer, and they were doing some weld fixtures on a rotary table, and the slip ring they were using was a $7,000 slip ring. And when I visited their facility, they haven't even started production, and they already had 2 failures with their slip rings. So it was just something that really came home to me was, wow, this is something that could be easily solved. Passing one air connection, one power connection through the slip ring and a rotary union, and no comm cables, allows you to mount solenoid valves and I/O on a rotary device and not have to worry about the communication cable. And as I mentioned several times, the automotive body and weld cells are probably our number one use for these. And when we say welding, people get a little concerned because of the noise of the welders themselves. And we talked earlier in the frequencies of most welders are going to be in the kilohertz or megahertz range, well below the gigahertz range that we're operating in. So there's been no problem in the environments that we've worked in the automotive side. And that's, again, been the number one user. And they've used it in their global facilities as their standard. Another one could be an automotive glass assembly. You have a lot of robots that are picking the windshields and things like that nature. Maybe using a vacuum system, again, having this controlled via wireless. End-of-line packaging and palletizing, and robotic to OEMs. And I even had a unique application where a customer had some medical devices, analyzers, and they wanted one central control system. And with the lab, they were having to move the analyzers around quite a bit. And so what they did was just simply use the one base unit, had a remote unit in each of the analyzers, and they moved it in and just plugged in the power wherever they needed it. So they didn't have to worry about a communication cable within their lab. I know we get a lot of questions from people because, again, their concerns and of, hey, how I guess proven is this system? As again, wireless becomes an uncomfortable subject to a lot of controls engineers that have tried to implement systems in the past. And we released this as a standard product in 2017, but we actually had our beta tester, or the company that really wanted this system from us has been using since 2015, and they're using over 1,500 units and their robotic cells, and their turntables and tool changers. And my personal experience with that users, I've gone in their facilities when they first received their equipment. We actually did some audits with them. So where we used the statistical analysis through the CSV files. So we went from weld cell to weld cell and did recordings of all that data. And we were able to, show that this was going to be a reliable system in that environment. And then even a little anecdotal thing too is some of you are aware that microwave ovens operate at 2.4 gigahertz. So we particularly tested around break time and lunchtime in cells that were near break areas. So when these guys were able to take the break and they might want to microwave their burrito or what have you, we were checking and making sure there was no effect on our device, and we saw none. So it was just something that we weren't thinking about, ahead of time, but then we realized, hey, we might want to check this and see what's going on. So we found a lot of little situations and we've had no problems. I know this one particular maintenance engineer was pretty adamant about the reliability of this, and he was a little concerned. And I can tell you personally, he would have called me on my cell phone if anything went down. And in the 4 years at his particular installation, he's not called me once. So that's telling me it's a good system. That's my kind of my personal sales pitch on it. So as an engineer, if I don't get a call afterwards and they're still running it, it's a good system, and not having to go in and support it when they go down on third shift is a good thing for me.
Hey, Mark, I see on this slide, I mean, some people are listening, but I see on this slide for our viewers that you have a link to a customer video.
Yes.
Can you send that to me so I can include it in the description so our viewers can watch it?
Absolutely. So we had one end user that was doing automotive welding, and they were so excited about the system. They were able to drop their downtime 60% in problems with cables and robotics and effectors. Since they were so excited about it, they were able to film some videos and allow us to share those videos. So I'll share this with you, Shawn, and this could be something that your users can look at and see this in action.
Excellent. Thank you.
All right. Do you have any other questions for me, Shawn? I'm just kind of giving you the kind of the nickel tour of the product, but is there anything in particular you can think of that I can answer for you?
Is this the last slide?
It is. I'm quick.
Wow, no, that was great.
I'm a Southerner, but I speak fast enough and get through this. And I just want to give everybody the overview, and I've done this enough that I think I cover most of the questions that people have and concerns, and certainly can address things further if needed.
No, I think that was a great overview presentation. I think even the people listening, they're going to get a gist of what you covered and all the detail. Even though they can't see the nice pictures you had of the product. Just so our viewers know, you actually sent me one of these systems, so we have it in the schedule to cover this winter. We still have products that were sent in this summer that we're covering, but I can't wait to try it because, and while there are a lot of applications for this. I actually know of many just plain IO applications where people want to buy a name brand product like SMC, but they may just have regular IO, digital and analog IO. So I definitely think you have there's two different markets for this. Is where you're going to have solenoids and whatnot, but also some just IO company. Some people just need some IO, and it's been very difficult for them to get that IO to get the wire run. So I'm excited to trying it out. I really am, and I really appreciate you coming on the podcast to kind of cover it with us. And I'll include all the links you send me in the description, so anybody who's watching this or listening will be able to see those additional videos and links to the product page and all that. But I think with that, I think we're done. Any final words?
No, I appreciate the time, and I think again this is a very unique system. And in my career at SMC, this has been one of the most exciting products I've seen. It solves some unique applications, and it also works well for even some standardized applications where you may not necessarily need the wireless. It's just a very flexible I/O system, and the controls engineers here listening, it's something that I think they could be excited to use and be very happy with it.
Yeah, and it's coming from a top tier company. If you don't know SMC, they're in the top tier with all the big people as far as quality. And that's really the most important thing when you're trying a new technology. Mark, I want to thank you again for coming on the show and giving us this update.
Well, Shawn, thank you for your time as well, and thanks for having me.
Well, I hope you enjoyed that episode of the podcast. I want to thank Mark again for coming on the show and giving us that overview. And I can't wait to try out the samples they sent in later this winter. But with that said, I want to thank you, as always, for watching or listening. And if you enjoyed the show, please remember to give us a thumbs up and a sub. And with that said, I just want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.